Hello, everyone. Welcome back to the Quantum Mic, and welcome to an interview. We used to do these back when I hosted this as a science communication podcast. However, now that we're a YouTube channel, I think it's very appropriate that we do some YouTube-based interviews. And now we do a lot of physics on the channel. That's because that's where my background is. But there's a lot more to science than physics. And so I wanted to bring in a, very cool science communicator as well as geologist, Gneiss from the channel. Nice name. Welcome to the channel, Gneiss. Very happy to have
Thank,
you.
yeah, thanks for having me. I really enjoy talking about science communication, and I have a lot of opinions, and I think it's incredibly important.
That's awesome. Yeah, so we're gonna talk a little bit about who you are, get people a little bit familiar with you, and then we'll talk about the science communication, uh, both in general as well as sort of the specific science communication that you do. And for I guess people who don't know who you are, they might start to be able to guess based on your skin,
My appearance,
your appearance.
yes,
Yeah.
my lovely cubic appearance. Yes, so I guess as a person, like I am a geologist. Um, I have I don't know. I'm a geologist. I'm a research scientist as a geologist. I work with analytical machines for the most part, so scanning electron microscopes and mass specs and all of that sort of stuff. The equipment that you need to understand what makes up something in the real world.
Okay. Yeah. So, you do analytical geology, right? Is the way that you've described it to me before, if I remember correctly.
Yes, yeah,
Yeah.
that would be like a correct way. The I, I I work at a university and I work with a lot of graduate students trying to solve their problems, I guess. Grad students and just regular faculty, researchers, and things like that. So, oftentimes, if you have a natural material and you want to know what it's made of, either elementally, isotopically, or what minerals are in it, and then abundances, and it's a big difference between like tell me rough percentages to tell me how many part per billion like you have of this thing. And so I operate some equipment that can do some of those things, and I have a lot of knowledge in those areas. So if I can't do it or we don't have that capability, then I kind of know where to send them off to talk to something else, talk about some other equipment or method or whatever.
Fascinating. Well, I've always considered geology sort of my second favorite science. Of course, I have sold my soul to physics. Um, the the strange, fluctuating devil that is physics. But, rocks, well, to put it lightly, rocks rock. Um, so, what sort of drew you into becoming a geology person?
Uh, that kind of is a that's an interesting question for almost any geologist. And I think if you ask any geologist, they will not tell you that they started out as a geologist. Most geologists find their way like into the science, and because of that, we often call it a found science. So I was in the Navy, and I was a nuclear electronics technician. And when I got out of the Navy, I got a nuclear engineering degree because that was kind of the easiest thing for me to do at the time. And I worked in industry for a while. I was a project manager for an electronics company for a while, and I learned everything that I needed to do in that job for the rest of my life in about 3 years. And I kind of just didn't know if I could deal with that. Like my pay was fine. I could have just coasted out. Like there would have been, pay advances. I probably could have advanced the company and stuff like that. But I don't know if that was really, I wasn't passionate about that. And I just wanted to do something a little bit different. So I still had some military benefits for college left over, and I decided to just back to college and get a degree for fun. And I didn't. I've always liked rocks. I liked outdoors. Like hiking, and I grew up out in the country, and I just literally almost like looked at my local colleges that I had and saw the geology department and was like, I like rocks, and I don't really know that much about them. And so I decided to go get a geology degree, and I fell in love with it. And through that, I learned like how important and all of the applications, and just wondered why I nobody talked to me about this like as like a kid or in high school or any other point like in my life. And so that's how I kind of like refell into rocks and geology and became my career.
That's awesome. Yeah, geology is sort of one of those sciences that you don't get in school. I remember in elementary school, you kind of, sciences were all kind of combined, but it was very much basic bio, basic chem, basic physics. And then in high school, or at least in my high school, you did physics, you did chemistry, you did biology. There wasn't like an earth science program, there wasn't an environmental science program. It does kind of fall to the wayside, unfortunately.
Yeah, it was the same for me growing up. We had an earth science class in high school,
Hmm.
and it was like earth science and planetary science like combined basically. And it was the class that you took if you weren't smart enough for the other science classes.
Mm.
There is a term in geology called or in college called rocks for jocks. So
Hmm.
it's often taught because you don't have I don't know, this is a long history, but like it's not focused on at lower levels. And so to have like an actual challenging or in-depth class at the college level, you have to start like from scratch. And so you're basically teaching people that basically things that I don't know, a middle school student could understand and learn to get them up to the point where you can actually talk to them about like modern science and things that are going on like in geology. And so yeah, it's a shame that it's not taught. And I'm actually going to be making an episode at some point about talking about like why how we've gotten in this kind of situation. But like the short of it is that like it's not it's not on like standardized test, at least in the US. It's not on a standardized test. It's not on like your ASVAB, not ASVAB. It's not on your like any of your college entrance test or
Hmm.
anything like that. And so there's no like emphasis put on it. There's no backing for it. And so why study it if it's not if they if you don't have a reason to do that. And so
Hmm.
because of that, it's just kind of left alone, and we end up with a generation of people that can't understand earth science or how it applies to them in the real world and anything. But yeah.
Hmm. That's a shame, honestly. It's a real shame. So much of what we deal with is made out of rocks. And I mean, you've highlighted that in many a video.
Yeah, something that I commonly say, like at least in real life, I think I've said it in one of my videos too, is that like if you like look at like currently look at anything around you, everything around you, and it was either mined or it was grown. And if it was grown, it was grown in soil, which is also geology. And so like geology has like a direct impact on like our lives like all the time. And I am an environmentalist. I am very conscious about the world and the natural state of the world and everything. But also like we need elements to maintain our society, and there has to be like some trade-off and understanding and an ethical way of like obtaining those materials. And yeah, all of that kind of revolves around like geologist and geology, and which has like this stigma of like petroleum and mining and all that's bad. And I would agree with you to some degree, but like I've said, like there's also the things that we need for society, and it's important to understand all those things so you can make like informed, good decisions.
Hmm. Well, I mean, talking about being informed about geology, I think it's time to sort of talk about what you do now. And if people hadn't guessed it, you are not just a science communication person, you're a Minecraft science communication person.
Yes. Yeah. So, what better tool to use to talk to people about uh, geology and potentially mining than a game called Minecraft? Um, it was so I started doing this basically back in COVID. Like before pre-COVID, I used Minecraft at like outreach events, like STEM like things as a way of communicating with kids and things. Just it's an easy place that people have an experience with, and then you can branch off from there to talk about like the differences and similarities, which is one of the things I do like in the channel. Like I like to talk and present things in different ways. I'm known for primarily geology. I also talk about color theory, but I often do these things with a a lot of I guess flair animations and interactive displays and things like that, all done in like vanilla Minecraft. And yeah, so when COVID happened, I was looking for a way to do this possibly this outreach stuff sort of virtually. And my initial idea was that it'd be really cool to have visual representation a visual representation of Earth's history in
Hmm.
Minecraft. And that was like the first thing that I really did. It's not the first thing on my channel, but I was working on it, and that was like the thing I was like kind of working on, and it is some of the earlier stuff on my channel. But so I'm currently doing uh, a modern or another second version of that with all of the knowledge that I have now and a lot more effort. But basically, it is a world in geology where one block equals 1 million years, and so you have this long progression of 4,500 uh, 50 67 blocks that represents all of Earth's history, where one block is 1 million years, and then along it is a diorama that kind of has a representation of Earth like at that time. And so,
Hmm.
and I have some friends that are working on it with me that we make custom models and all that stuff. So we have like flora and fauna of the time and all that stuff that we're working on and implementing and everything.
That's fantastic. Yeah, I must say I really like your videos. It may be obvious as to why why I asked you to come on. Um, but honestly, for people who don't know Nice Name, which I'm assuming, based on the channel count for both of us, they probably know you and they came here to to watch this interview. Um, if you haven't watched his videos, you should. They are fantastic visual masterpieces, sort of showing things. I must say, I think my favorite one or favorite ones were the ones where you took the ore quantities and you compared them to um, the regular amount of like how much iron is mined out of the earth every year in
Yeah.
comparison to like a square in Minecraft or something like that. I don't remember exactly, but
Yeah. Yeah.
those ones were
That's
amazing.
comparing. There's a couple different ones that are
Hmm.
out now. There's a general one that compares like a set volume in Minecraft, like looking at, the copper and gold and coal and all that stuff, and then comparing that to the production, our worldwide annual production in volume as well. And then I have one on iron ore, and then another one on coal and diamonds. And I'm making the other ores that are in Minecraft. Next, I'm doing gold and copper. But I also really enjoy those. I actually learn a lot. Like it's interesting, doing a lot of research and being involved with these videos. It takes, months to make some of these
Hmm.
and do all the research beforehand and then all the visuals and everything. And the coal and diamond one is the most recent one of those like in focus things, and
Hmm.
it's my favorite. And the part I was like impressed about, it changed my understanding of climate change with seeing how long it took Earth to produce like our coal,
Hmm.
and then how quickly we've burnt through it. Like we've basically used up like half of the Earth's total production of coal, and it we're not making more at nearly that speed or anything. It took millions of years to produce all that coal, but yeah, it was kind of eye-opening. It's going to be something that I like use going forward to try to communicate to people that don't have an understanding. And I think that people, if you don't if you don't know if you're not here from me, uh, you don't need to know anything about Minecraft to like see some things in my videos. I Some of it is very, you have to have some understanding of Minecraft, but a lot of it is more I don't know, relatable by everyday people for things.
They are fantastic videos, I must say. I'm
Thank
really
you.
glad I stumbled across your content. Um, so I guess talking about uh, that sort of educational content. This interview, of course, I pitched to you in terms of we wanted to talk about science communication, and you have many opinions, you've told me.
Yes, yes. Like yeah, it's almost too many and too many
Hmm.
things to like really like just broadly talk about. But
Hmm.
uh education and science education in general is so important. It's trying to be not too emotional about this. It is like what makes our society. And if we are unable to like pass down that knowledge, then like that is a failure of the society. And we have like a generation or more of people that have kind of don't have the ability to do critical thought and analysis of things, and not to get too political, but we have a lot of people that are able to be tricked by charlatans, and not really assess like what they are seeing and view what is true versus lies. And it's very alarming to me
Hmm.
and many people. But yeah, so uh, yeah.
Yeah, I mean, I was going to ask about that because in this day and age, we are in a period where there is more misinformation than I think ever before, and scientific literacy is I don't know. I don't know the stats, but it feels like it's dwindling day by day. Um,
Yes,
mm,
I think that the understanding of science and the ability for people to understand science is it's twofold. One, our science is advancing, and you need to have more and more niche understanding of a certain field to be able to understand what is the new in that field.
mhm,
And on the other side, our education is sliding, and we are unable to uh, so that the gap between um, what is the forefront of a scientific field and the layperson's understanding of science is widening.
mhm,
And so, um, you know, I think that, it is important to have people that are able to break those things down and be able to communicate the cool things that are happening in like sciences to lay people so they can feel more connected and understanding like what's going on and everything. And uh I don't know, it's also, it doesn't
mhm,
really help that the news only really covers like the more inflammatory, catchy things when
mhm.
maybe that's not the point of the thing or what the scientists like, are actually trying to get to, or point out that, the science keeps changing their mind and not, actually learning new things and
Mhm.
changing, our understandings, which uh, is the point of science.
Yeah.
But yeah.
Yeah, it's unfortunate. But I mean, so I guess as a science communicator in this day and age of misinformation and all that, uh, fun stuff that, we have to deal with.
Hmm.
How how do you find it's best to combat I don't know, either people who try to swindle scientific information wise or perhaps just help educate people who may have been, fooled by those scientific conspiracy theory style people or whichever.
Mm.
I don't know which is the more I don't know which group you would deal with the most. I mean, if I was talking to like an archaeology person, definitely the conspiracy theory side, or they deal with heavily there. But I
Yeah.
guess what does geology face out of that, and how do
I
you combat it?
It's a bit strange. I think that since geology is kind of like you don't have like a popularized geologist, I guess. Like you have like Indiana Jones and you have like this anthropology stuff and you have like I don't know, I'm trying to think of like the movie Stargate and things. Like you
Hmm.
have like these like sensationalized anthropological things. Archaeology, anthropology is kind of, you know, still in like the public mind.
Hmm.
And like if you go to like paleontology, maybe you have like Jurassic Park and you have like people out, in the, dirt digging up things. Uh, but geology, since everybody kind of has this like misunderstanding of it, I often just get asked like, what do you do or what does a geologist do? But like I think they're mostly the biggest thing that are confronting or I confront is like misunderstanding of what like a geologist is. Like if I tell somebody that it's geologists that are the primary people that are studying climate change, like a lot of people are like, what really? Like it's like yes, like they're the geologists are uh I don't know, fundamental to like water quality and all sorts of different things that um I don't know, just the geology word has a bad stigma to it. And so normally that's like what I have to deal with. I have some people that are, these comments or people that I deal with in real life too that are
Hmm.
not researchers and things like that. I interact with the public and things that have questions about the age of the earth and things like that due to
Hmm.
their religion and things and so that's always like it's delicate because like you don't want to just say no, I just fundamentally disagree with you, and but you can try to talk to them about things to see where their misunderstandings are. This doesn't just go for like just age of the earth, but just in general, like
Hmm.
where is their misunderstanding at? Like, can you approach it from a different direction? Like, where does their view of reality separate from actual reality or your view of reality? And try to talk like about that. That's one of the things that's it's never really like a goal of mine in like my education videos of
Hmm.
like trying to trick people with Minecraft, but it's more of a Minecraft is the starting point. Like it's something that is easily understandable, everybody has experience with. And so if you can go from there, I normally think of it as like physical places in like thought of like I have a thing that is here and I need to bridge to a thing that I want them to think about. And so then I
Hmm.
have to figure out what they understand and try to get them to where I want them to go to. And so that's kind of how I like think about
Hmm.
trying writing scripts or things like that or talking about topics. I try to get to the most common denominator of starting and then go to places that make them think about things.
Yeah, I mean that brings up one of I think the biggest struggles when it comes to communicating any information, which is where is everyone's baseline, right? Like you're putting out videos here for thousands, hopefully even millions of people to eventually like to see, right? Loads and loads of people are gonna watch them. Not everyone's gonna come in at the same level of education. Right? You're
Yes.
gonna some people will they'll know what quartz is and they'll know what a sedimentary rock is, and then someone else will show up and they'll go, I know what dirt is, and that's about it. I mean, how do you choose where your starting point for information is? I
Hmm.
guess. For when you're producing a video, where do you pick this is my baseline of the understanding of the viewer?
I try to do my videos without assuming that anybody has seen anything else that I've done.
Hmm.
So my baseline is that they have some experience in Minecraft or in real life. And if I can, show pictures or video from those two things and show like this is how this operates, that's normally where like I start from. The trying to think of like an example in like a recent video or something. But oh yeah, so I did a very popular video that came out recently was a video about mountains, the scale of mountains,
Hmm.
and it has I wanted to talk about how big mountains are in Minecraft versus how bigger mountains are in real life. And so obviously I start with mountains in Minecraft and talk about their scale and everything. And then I've found a mountain that is nearby me in the Midwest that is as tall as a Minecraft mountain, the tallest possible Minecraft mountain.
Hmm.
And it basically looks like a hill when you put it
Right.
into the game. And so, like, that's something that, I assume that everybody has seen this mountain and I'm showing them a video of it. And that's like where, like, I'm starting.
That's great. Yeah, I think that's a good way to approach things. Uh, I just want to pivot back now, actually, to your geology background. And I mean, this has all kind of been covering geology things in general, but um, when it comes to things that are misunderstood about geology, what do you think is sort of your number one white whale of topics, I guess, or the thing that's not a good analogy. We're gonna cut that. What is your number one sort of concept that you think most people don't understand or misunderstand, geologically speaking?
I think it's the I think it has to be the scale of time. I think like even people that are like, I get it, like and these dates and everything like that, but like actually having a tangible like understanding of geologic time and the processes and how long certain things take and like something like the Appalachian Mountains, which are hundreds of millions of years old. They're like old mountains. They're worn down. There used to be a huge mountain range like the Rockies,
Hmm.
but now they're just kind of there's not a lot of Rocky Mountain of the Appalachians left anymore because they're old.
Hmm.
But they're relatively young compared to like Earth's history. There were plenty other mountain ranges like previously. Um, in the mountain that I previously talked about that's near me, Rib Mountain in Wisconsin, that is the heart of an old mountain range, and now it's barely 200 meters tall. But it used to be a huge mountain range, and it's just like flat. So anyway, the concept of geologic time and trying to wrap your brain like around that, I think that is something that is probably even the most misunderstood or hardest concept to understand, even amongst geologists. I think that is it's really hard to deal with giant like numbers.
Hmm. Anything really, really big or really small is just kind of gets out of the scope of the human brain.
Yeah, I imagine that you have the same issue with like subatomic particles and things. Like even once you get down to subatomic, I was like, oh, it's probably everything's very small, but I'm assuming there's a wide range of sizes below that is hard to deal with.
Yeah, you get to like an angstrom, which is, I believe, 10 to the minus 10 meters? 10 to the minus 10. It's the diameter of a hydrogen nucleus. And that's not, you think about that and the unit it doesn't process how tiny and infinitesimally small that is relative to everything else and how much, how many atoms are in one pixel on the screen are going to
Yeah,
be
yeah.
like ridiculous.
That's a so I'm hoping to do this episode about I'm going to do an episode about geologic time also, and I have a couple ideas of how to try to relate it. One of the things is like computing how many atoms of uranium are in a block of granite, which is going to
Mm-hmm.
be like in Minecraft, granite, so a meter
Mm-hmm.
cubed,
Yeah.
which, uranium is not part of the normal atomic structure of granite, but
Mm-hmm.
it is abundant enough and it's in a lot of granite. But the number is going to be massive. Like the number is going to be huge,
Yeah.
uh, even though it's a very, very small number because the number of atoms that are in it are is just astronomical. Uh, so yeah, it's going to be.
Mm-hmm.
I don't know what those numbers are going to be yet, but it's going to be very very interesting.
They're gonna be big.
Yes.
One of the so as a physics person, I don't deal a lot with rocks and geology in my personal time, but I'm an experimentalist. I work on experiments, and so I do high energy particle physics. We, speed things up, and because we speed them up so much, they produce a lot of radiation. So to one, shield them, and two to shield us, we put
Hmm.
them very far underground. Um, but the one element of geology that we always worry about, has to deal with that background radiation from the different rocks. So, what sort of rock do we want to build our detector in? Um, Part of that comes down to, oh, is it easier to drill this giant tunnel into granite or into sandstone? But also, how
Yeah.
much background radiation can we get from this rock, or how much shielding does this one type of rock produce?
Yeah.
uh, which is it's kind of cool. It's its own little thing. I did one video on that, which I must say was not very good. But it's a far more interesting topic than I gave it credit to. So maybe I need to redo that. But
Yeah.
I
Geology sneaks up on you.
it
It's
does.
there's lots of applications.
hmm It's one of those things people don't quite realize. Uh, thank you again for coming on. I just want to wrap it up with two very fun questions, I think.
Sure. Yeah.
All right, you're a geologist. What is your favorite rock or
My
mineral?
favorite my favorite rock is banded iron formation. It
hmm
is uh it's a it is a sedimentary rock that is billions of years old. It is a record of early life on the planet because before it was really starting to be deposited, the oceans were very warm and acidic and had a lot of iron dissolved in them. When photosynthetic algae started to grow and produce, it added oxygen to the ocean, and then the oxygen immediately reacted with the dissolved iron and started rusting. And so you had like a billion or so years where the oceans were rusting, and the
hmm
rust would fall to the bottom and it would form these banded iron formations. And that is what we mine today. For that is where we get all of our iron from for all of society, and they look beautiful too. They can be metallic looking, like with hematite, and they have bands of jasper in them, and they can have some other minerals in there as well. But I have like a lots. I have lots of samples of them from various places around the world and everything.
Yeah, that's a great answer. Banded iron is it's so pretty and such an interesting rock. Um, and I guess lastly, um, back in ye old days when I used to do these interviews, I used to ask the last question, the same sort of last question to everyone that I had on. So I wanted to ask you, uh, what's been like a scientific experience, interaction, whatever, an experience that you've had in the scientific community, that's really spoken to you or really resonated with you, you've considered very important, just sort of something personal.
Like a a thing, an event that happened in my lifetime,
Yeah, I mean,
or
it's
or
some
to
sort
me
of
personally, like that I was
just
involved in, or
yeah, something that you've done or been part of or whatever that you thought was very important or very cool or that you I don't remember how I used to word this question. I should have written it down. But yeah, it's like what's an important thing, that experience or event that you've done in the scientific community that has resonated with you, sort of thing.
yeah. I
And
guess I can say I don't know about it didn't drive me. It's more of like a fulfillment like
Mhm.
thing that I've I got to work in Madagascar, and like that was a place that child me would like dream about like going, and just because of like the biodiversity and all of that stuff that's always like, you see all that stuff. And like I got to go there as like to work with some biologists as like the geologist on a team of paleontologists that were like I was adding geologic context to like some sites that they were working on and stuff like that. And it was just a place that I never thought I would go, and never a thing I would never thought I would do. And it just seemed very surreal like when I was there, that it was like I was like, oh my, this is I can't imagine like any other time. And I love going, I would say vacation, like, but that is like the best sort of vacation, like going on there and actually doing things and exploring and meeting like the local people and experiencing new foods and all that stuff. It's probably up there with like, I don't know, the top experiences of my life of like, just like kind of, I'm just impressed that I'm impressed that I'm able to do this sort of thing.
Hmm.
It was very, very cool.
That's amazing. Well, I guess we should wrap up. So once again, I just want to say thank you very much, Nice, for taking the time out of your day to do this interview. For the second time, for the people for the people who will never see this, we did a whole other interview like 3 months ago when I when I was at CERN, and it did not go. It did not record very well. Um, but yeah,
Yeah.
thank you again for putting up with the rearranged time and doing two interviews with me. I really appreciate
Oh,
it.
my pleasure. Thanks for having me. It was good talking. And yeah, this was a lot smoother video than last time. Trying to talk through the pause and everything like that. But no, it was I always enjoy chatting about these things. I think I value education like very high, and I like talking about this stuff. So thank you for having me.